Hi, I'm Cliff Emmons, CEO of OXYS. Our mission at OXYS is to help small and medium-sized manufacturing organizations realize the productivity gains possible through Industry 4.0, also known as smart manufacturing. In this video, I'm going to answer some frequently asked questions about our smart manufacturing technology and services that we offer here at OXYS. Much of the content of this video are excerpts from my recent panel discussion at the IIoT World Manufacturing and Supply Chain Days. If you wish to view that entire panel discussion, you can do so by connecting through the link shown below. So let's get started with our first question. What is predictive maintenance? How is it done? And what are some examples? And what can it do for your manufacturing organization?
Appreciate you both not only answering that question, but also providing the why behind it, right? We talk about the sources of unplanned downtime. We talk about, looking for patterns to avoid failures and catastrophic failures. Cliff, same question for you. I'd love to get your thoughts, but also maybe we expand on this a bit, right? How are predictive analytics used on manufacturing equipment to predict failures, and how is your team using this information to be successful in predictive maintenance engagements today?
Sure, Chris. And first of all, I think John and Martin's thoughts were spot on, and I think you're going to actually find a lot of alignment with the example that I wanted to share, which actually comes from a use case with our Spanish partner, Ingura IIoT. The application is for a large CNC machining centers where there was a desire to predict the failure of the main spindle bearings. And the technology used to actually implement this predictive maintenance were acoustic sensors, basically listening to the condition of the bearings. The predictive analytics approach we used was unsupervised machine learning algorithms. And I'm happy to say that we actually achieved a 10x savings in maintenance cost because the customer could replace bearings before they failed, which was exactly the point that Martin was making. Also wanted to point out another interesting point that correlates with what was brought up before was that it would actually take another 4 additional days from the time that the bearings were replaced predictively to the point where it would actually fail for real. And as mentioned before, the cost would be significant for that major failure if it went to failure. In fact, it would have been definitely a 6-figure cost to the manufacturer to replace, as opposed to a 5-figure if it was done predictively using these algorithms. So also wanted to say we're currently now working with the same partner to use this approach in other predictive maintenance engagements, as well as applying these same techniques to CNC tool optimization. And actually, before I go there, Chris, I just want to, again, emphasize that predictive maintenance, for that matter, also prescriptive maintenance, which to John's point, gets to the root cause of why you need to do that predictive maintenance, and actually is a competency somewhat considered above predictive. It's extremely important to our customers. And we at OXYS have the know-how on how to deliver it. After all, as we mentioned before, you're not making money if your machines are down, especially if it's unplanned downtime. Another question we get from our customers, both from medical device OEMs, as well as their supply chain, is, what opportunities are there for small and medium-sized enterprises, the actual manufacturing organizations that form the supply chain of the medical device OEM?
We're going to be shifting the conversation here to a big topic that I think a number of people will want to discuss: supply chain. John, Martin, you both gave your thoughts there. Cliff, do you have anything you want to add to this topic before we dive into the supply chain question?
Sure, Chris. So I led product development teams for over 20 years, commercializing minimally invasive surgical instruments, as well as diagnostic equipment. And a robust product development process requires a really strong connection with your supply chain. Because there is a goal to optimize that so-called value triangle of performance, quality, and cost. And also, when it comes to medical devices, they often have many physical components that are dependent on their related manufacturing processes. So metal machined, metal stamped parts, plastic injection molding, as well as plastic extrusion processes. All of these processes are prime opportunities to apply predictive analytics to analyze them. And the goal is for better precision, which is key to medical and surgical devices, as well as higher quality and lower costs. Now, interestingly, studies on smart manufacturing over the past 4 to 5 years show it's the medical device supply chain is actually lagging other industries such as automotive and electronics, which is completely understandable because it's a highly regulated industry. So change, adoption of new approaches, it's slow. But there's another reason. Medical device supply chains often are made up of SMEs, small and medium-sized enterprises, also known as mom and pop shops, or these days, conglomerates of former mom and pop shops. Therefore, they don't have the same level of resources as their tier 1 customers do when it comes to researching and adopting these new methodologies. And I think this is where our company, OXYS, is focusing on the democratization of Industry 4.0 technologies and services. My advice to these SMEs is to, one, find partners like OXYS, like Martin, like John, because actually more is better, okay? Secondly, to focus on a real issue versus boiling the ocean. Companies make more progress when they are solving a specific issue as opposed to necessarily implementing something company-wide, like an MES system for the shop floor. Second point, engage and train your frontline employees on IIoT data, predictive analytics, and other Industry 4.0 technologies and methods. Because at the end of the day, studies showed that the organizations that follow these points are more successful than those who don't.
Our third frequently asked question is, besides predictive maintenance, what are other manufacturing challenges that can be addressed through predictive analytics?
Okay, so that said, one of the lessons I've learned from my product development days is VOC, voice of the customer. And that begins with listening to your customers and understanding their challenges. So that's what we've been doing, listening. And what we've heard from our customers is after reducing downtime, process optimization is the key to their continuing success. In the case of our CNC machining customers, especially those in the medical device supply chain, that process optimization translates into tool optimization. And let me just explain what I mean by tool optimization. Once a CNC program has been locked into both the performance, precision, and accuracy, as well as the quote quality corners of the triangle I've referred to, cost is the last parameter or corner to optimize. So getting maximum tool life, without breakage and maintaining performance and quality while doing so is the key. All right. So we have another example, again, from our Spanish partner, IIOT. It's a toolware focus use case, a proof of concept in the EU. It's still underway, but well into it. The application is heavy CNC machining for a railway systems manufacturing organization, where they take rough castings and they're finished through CNC machining. We have some great results to date. The first of all, actually being able to detect a broken cutting edge on an end mill tool, and also being able to detect deficiencies between actual versus target machining parameters. In this particular case, we were able to detect when spindle head angular speed wasn't achieved within the current program time window. Now, in both these cases, real-time anomaly detection was achieved, which enables intervention and corrective action by the machine operators. So, and just to know, I want to say, we really kind of feel this is our secret sauce at OXYS and IIOT, is the ability to acquire and analyze time series data, quote, at the edge, at the actual machines. So getting back to the POC, as I mentioned, it's still underway, and we're currently at this detection and alert level now. However, we are developing predictive interventions for both tool wear and breakage prevention. I want to shift to a second example that kind of contrasts the big machining process of the EU case with a pending medical device supply chain CNC machining process POC that we have pending here in the US. And in this case, it's a matter of fine machining of small, high precision parts. However, the good news is we're able to apply the same tool optimization and predictive intervention methods as we were in the heavy machining case in the EU. And the current goals of this pending POC are to improve part quality and reduce variation in SPC, statistical process control samples, as well as reduce discrepant parts at the in-process inspection checks. So coming full circle, I just want to say these goals were established through the VOC process, targeting the current customer pain points of part production and yield, as well as downtime due to corrective actions for the quality of the parts. So I think those are a few good examples of process optimization that's still achieved through predictive analytics. So again, I think the tool optimization example is a good something where you kind of shift away from the machine and really look at what is it producing, right? I think one of the things that we know is the advantage of, say, first going after these tangible challenges on a specific process is once you put these systems in place, then a lot of the other condition monitoring types of things come along with it. So OEE, overall equipment efficiency, and things like mean time between failures, all these things, remaining useful life, which is along the lines of tool optimization. All of these things come into play, but at the end, the result, is the same when they're applied, which means minimize downtime, optimize the performance triangle of performance, quality, and cost.
Another question related to manufacturing challenges is, what are additional root causes of manufacturing issues that can be addressed by predictive analytics?
And actually, if I could just build on that, Martin, first of all, just want to go back to quote, consistent material. Time and time again, over my experiences, all it takes is a new batch of incoming material, that's used after months and months of production, that there is a ground shift that takes place when that new material comes in, even though it's within all the parameters that, are specify the material, it's still different. And you need to be able to use these tools to actually sense those changes right from the very beginning. I also want to say a great example about the French fries. We actually also at OXYS had done a continuous manufacturing operation for a lyophilizer, a large lyophilizer in the pharmaceutical industry, where we were actually monitoring over 56 different channels of material and actually successfully predicted good and bad lots. Only, a few, actually half a day into a multi-day process. So I agree with you. Predictive analytics really turns on the heat when the more variables you throw at it, the more capabilities there are.
Our fifth frequently asked question is, what IIoT, or Industrial Internet of Things, data sources can be used to feed the predictive analytics to address predictive maintenance and process optimization?
I think along the lines of IIoT data and what to be gathered, kind of just backing up just a little bit to comments from John and Martin. First of all, I would say, again, to John's point, all of the additional sensors you can put onto a process, we've actually used all of those, and we definitely are behind them. To Martin's point, the best place to start is if there is a controller involved in the process you're working on, the PLC's data that it's gathering to keep in control is real-time data that is a treasure trove. So in both cases that I mentioned earlier, whether it was the CNC machines or the lyophilizer, both of those PLC controllers gave us a wealth of knowledge to start with, and only then we selectively decided if additional sensing was needed. So that was great. The other point was about what are you actually detecting, and a great point came from John about that anomaly detection is critical. I will offer that trending is also another important aspect. And we, again, through different methodologies, and I know there's a lot of questions about AI in there, AI machine learning, we'll get into them, but another technique from the machine learning world is a BIC, or a Bayesian information criteria. We've effectively used that to tease out the subtle shifts that take place in a trend over time. So it's not just the anomaly detection, but also trending.
Another question, one that CEOs often ask, is, what are the benefits of pursuing smart manufacturing technologies and practices? And specifically, what separates the leaders from the laggards?
So, okay, why should this be important to CEOs? Well, of course, I don't think there's any CEOs out there that purposely intend to be a laggard as opposed to a leader. They want to be a leader. So I wanted to actually tell you a little bit more about that study that you mentioned. And first, let me just give credit to the collaborative parties that initiated the study I'm going to be referencing. McKinsey and Company, a well-known, a well-known consulting firm up here in the Northeast, and MIMO, which stands for MIT Machine Intelligence for Manufacturing and Operations. You can always count on MIT on a really good abbreviation. So the study is the MIMO McKinsey MI Machine Intelligence Research Study, and I'm going to provide a link to that study in the chat box. The current findings are based on its one-year survey with about 100 companies. And the second year of the survey is now open, and it has a goal of actually having 1,000 companies to participate. So I highly encourage any manufacturing organization that's currently on a quote, and you mentioned this, Chris, a digital transformation journey, whether it's light or full blown, or if they're considering starting one, to actually take this survey, as it will be a multi-year study. So let me share some of the key takeaways that I've actually mentioned previously in our discussion so far. First of all, as we've said, it's focusing on what distinguishes the leaders from the laggards. Okay, and along those lines, one of the interesting point is they describe various types of groupings or clustering in the survey. And one group was called executors and another was called planners. And the executors are actually doing better than the planners, okay? And these executors do exactly what I mentioned before. They focus on a specific pain point and they look to fix it, as opposed to necessarily taking what the planners do is they try to create the perfect, complete solution and wind up boiling the ocean. And many times, trying to employ technology like an MES system before they've really targeted the true pain points and the goals of what they want to achieve, in the actual journey. Third, and this is another point I mentioned before, is leaders train their frontline employees on these very topics that we're discussing today: IIoT data, predictive analytics, other Industry 4.0 tools, and the results are significant. Their progress above the laggards is measured in the KPIs on the order of 5x. So, significant orders of magnitude better, than the laggards. So, and I'll kind of give my final thought on this, idea of where should they be going. And again, maybe before I do, I just want to emphasize what was mentioned earlier. I think another good phrase for CEOs to keep in mind is it really is an ounce of prevention is worth a pound of cure. And you know something, if you price it out and it's not, then it's not the right solution. So finally, let me just say this. The goal of this digital transformation that MIMO is kind of concentrating on is the idea of, quote, true machine intelligence, which is they define as a machine that can actually adjust its own performance autonomously based on historical and real-time data. Now, obviously, that's a very lofty goal. It's not going to be here next year. It's going to be in the future. However, as we described today, you can make significant gains in your organization just by taking the first steps of the journey we've described and the topics we've discussed on this panel.
Our final question is, AI, or artificial intelligence, and machine learning are often referenced along with predictive analytics and smart manufacturing. Exactly what is AI and machine learning, and how do they impact smart manufacturing results?
Again, I think we could have another 3 hours on AI and machine learning alone. I think very simply, I just want to say, for me, AI and machine learning are basically the numerical computation methodologies that allow the predictive analytics that we're speaking of today. And the point is, get started with it now, because they'll only improve over time, as will the hardware that can process it even faster. So don't wait, because you can get great gains from it today. As far as, is it changing things? It's changed things for our customers relative to replacing spindle bearings. And, it's also helped, in optimizing machining processes. So the productivity gains are very real from the tools that are available today. And that's how come we employ PhD data scientists, because they understand when to use unsupervised machine learning methodologies, as opposed to, various types of neural nets trained on supervised learning of, reinforcement data, et cetera.